Okay, so I have to picture the graph based on the degree. What's the degree of number 1? 4. What's the leading coefficient? 3. So this is an even positive graph. So even positive means that both arrows are pointing up. This information here is how you fill in your question marks. If you're not getting this, then you're lost on it. So when I think about the right arrow, even positive right arrow is going up. So I'm going to take the question mark out and put a plus sign in. When I think of the left arrow, it is also going up. So I take the question mark out and I put a plus sign in. This one, number 2. What degree is number 2? 3. So that's an odd degree. And what's the leading coefficient? -1. So we're odd negative. So I have to picture a negative slope or negative correlation. That means you start high and end low. Odd is opposite ends. So I should have opposite signs here if it's an odd degree function. On the right side, my arrow is pointing down. So I'm going to take the question mark out and put a minus sign in. On the left side, my arrow is pointing up. So I'll take the question mark out and put a plus sign in. Well, we're doing it again for like 4 more days. All right, get out your assignment. Let's see how you did. Yeah. Yeah, popcorn, that's what we're talking about. All right, you guys. My answers here present opposite to how I've been doing it. So let's just accept that and look into it. So here's how you should check your work. This is left side. So when my X was pointing minus, my Y was minus. And then I put the right side below it. So when my X is positive, my f of X is also negative. So both arrows point down on 19. Y is what? Yeah, it's just written differently. There's no standard way. So sometimes, and actually on the SAT, they're going to word this completely different, and you have to know what the symbols mean. The ACE math book, totally different. College algebra book, totally different. So try to make it standard, but you should also be able to mix it up and still be able to match that this means left and this means right. And this means both arrows are going down. All right, 20. Again, the left side I put first here. So look where yours is left is probably on the bottom. So I tell you to do it. You should pick them pointing down. So for left, you should have picked down. For right, you should have picked up. $21. For left, you should have picked up. For right, you should have picked up. They're both going up. 22. Left is up. Right is down. Does anybody else want to turn in their problem for the project? Just have them through. Now I know some of you are like rushing to get that in. If you still want to do the project, just turn it in after school. I'll still allow you to do it. There's a lot of people doing the project, so I'm a little bit flexible about this part.
No, I did the problem. I just need everyone else to be in the video. Well, not like that. Okay, so what do you need? I just want to make sure. It is. It is now.
Okay, I approve this thing. Keep that. All right, and then here's your negative, odd, positive, even. If it's odd, the ends are opposite. And actually, it's based on the x So odd is either like this.
That's embarrassing. That's embarrassing. My left is right. Stop. Oh my gosh. That's my bad.
That's based on its negatives or not. No, I just do my feels like
He's so funny.
So, really, forever now, from this point forward, when you're looking at an equation, you can start to picture the graph, picture what the ends look like. You should be categorizing your equations even and odd now. Okay, so as you move forward in math, the visual of what it looks like graphed and the problem that you're looking at, they should really be kind of intersecting in your mind. So you're looking at an equation and you're already starting to picture all of these different qualities and characteristics. So step one, you see your equation, decide, is it even or odd? Is it positive or negative? Know the end behavior before you even begin working with it, okay? Next, you're gonna factor it. So factoring was probably the most difficult part of the quiz we took. So that's where this is going to be challenging you, is go ahead and factor that equation. You're going to set them equal to 0, and you're going to solve the equation, or the factors. And then you're going to make a graph, and you're going to plot these zeros, they're x-intercepts. So we're going to put dots on those, and then we're going to draw our line beginning and ending with the correct end behavior. Number 4, there's a lot going on there. It's a lot to write. There's actually a whole definition there. So I'm going to talk about this multiplicity in just a moment. I'm going to wait and let you guys catch up. I know you're writing a lot, so. I'll talk about multiplicity multiplicity in just a moment. Okay, so multiplicity means oh I know, I'm gonna do a little example. I'm gonna do 2 full examples with you. So what I'm doing right now doesn't count. You don't need to copy this. I just want to try to show you what I mean by multiplicity. It means that a factor represents more than one solution. For example, if I was to factor and get a factor, and this is what I got for my factors. This because it's x squared counts for 2 zeros. So I say this as a multiplicity. As a multiplicity of 2. So when I solve it, you don't have to write this example. I have other examples for you. I'm just telling you this definition. I solve this one, I get x equals 5. I solve this one, I get x equals 2. When I go to graph them, I have a dot at 0, I have a dot at 5, and I have a dot at 2. Now really this is 1, 2, 3, 4, 0. So I only have 3 dots. If anything has a multiplicity that's even, in even multiplicity, you touch the x-axis and you turn around. It's a touch and turn. So this would be an even function. I'm going to start up high. When I come to 0, instead of going through it like it's an intersect, it touches it and it bounces back up. A touch and a turn. The other ones I go through. They're intercepts and I move right through them. But when there is a multiplicity and it's even, it'll touch that point and it bounces right over up, bounces and turns up. Okay? Right here, I would have to plug this number, which it looks like is 1. I'd have to plug 1 in for x and get a y out, and that would tell me how high to go on that turning point. I would also have to plug in 3 and 4 for x, and that would tell me how low to go here to turn. So at some point I'll be plotting these points. Today, we're just going to turn wherever we feel like it. It's a sketch. So today you have to get the end arrows correct. You have to get these points right, and you have to move through them correctly. But we're going to work towards making a whole table and getting these depths and heights done correctly. Right now, you just need to hear me say that multiplicity means instead of moving through the point, it touches and it turns around. That's an even multiplicity. Odd can go through. Well, both of our examples have it, so are you guys ready for the first problem? I can wait. This is our first one. We're going to do 2 together. The directions are to sketch a graph. Alright, let's get started on this example. I'm going to do an even with you and an odd with you. Oh, this is the odd. We're starting with the odd one. Alright, so let's move through these steps. Alright, it's 2x to the third minus 12x squared plus 18x step one is to decide what the ends should look like to get a visual on this. So I've highlighted, the numbers that determine the ends. The degree is 3. The leading coefficient is 2. So this is an odd positive graph. So that means it's going to have opposite ends. It's going to start low and end high. So that needs to be like some paper. You're totally out of paper. Alright, next you have to factor. So this has a greatest common factor in it. So go ahead and take out a GCF. Everything divides by 2 and x. Factor a GCF. And then keep going. Factor this polynomial like you did on the quiz. Okay. So I'm going to divide a 2 out. Divide x out. X squared minus 6x plus 9. I'm going to go on and factor again. What multiplies to 9 and adds to negative 6? That would be x minus 3, x minus 3. That's the factored form. Now we'll solve these factors. So I'm going to do 2x equals 0. X minus 3 equals 0. And I really don't need to do it again. So actually, x minus 3 has a multiplicity because it's the same thing twice. So I'm going to divide by 2, and I get this x equals 0, which is one of my x-intercepts, plus 3, and I get x equals 3. I'm not going to do it again. I'm just going to go ahead and say that this has a multiplicity of 2. So I'm going to have to touch and turn at the 3. All right, so after you get all that done, it's just time to graph. So draw your x and y axis. Looks like I have a big dot at 0. A big dot at 3. And then I'm going to connect these correctly, so I'm going to consider the ends. I decided it was odd, positive. So I'm going to put an arrow down here and an arrow up here. And that's going to guide my graph. Those little arrow heads guide the graph. So I'm going to start here. I'm going to go through the first one. This one I'm supposed to touch and turn. So I'm going to touch it, and I'm going to turn right back around, and I'm going to end with my arrow. And that's the graph. It's a sketch. It's not perfect. Sketch. We're going to get more precise because our next step is to make a whole table. Sometimes with these, you have to plug in like 8 points in your table. But right now, we're just sketching.
Can you say again how you graphed, like how you got the lines?
Mm-hmm. So you know the 0 and the 3. And I didn't, before I even had this, I just had this sitting here. And I just had this sitting here because I knew the ends should be opposite. So then I start my pencil down low because I know the end. and I go through that, and then I end up high because I know the end. And a lot of it is just practice, you know. So you might get it wrong a couple times and have to fix it, but it's the kind of thing you have to do yourself and investigate. Check your answers. On the next one, I'm going to even use Desmos. I'm going to pull up Desmos so we can look at our sketch compared to Desmos. And you just kind of start to learn where your line should fall. All right, next one. So that was an odd example. Our next one is even. So the book, I believe, and sometimes whatever, your polynomial isn't presented correctly. So I wanted to put this disclaimer out there. Make sure everything's in the right order. So sometimes you gotta rearrange. Like this one's not set equal to 0. So I'm gonna have to rearrange this guy before I even start. So just as a disclaimer, your polynomials have to equal 0 before you factor or solve. So this isn't ready to go. I can't even begin until I take this 6x squared over to the other side. So the real thing I'm focusing on is negative x to the 4th plus 5x to the 3rd minus 6x squared equals 0. Now that it's equal to 0, we're ready to start. So you need to figure out if you think it's even or odd, positive or negative, and start to picture how you think the arrows should look. Okay, the degree here is a 4. So it's an even function. The leading coefficient is negative 1. So it's negative. So even negative. I'm going to start with both my arrows pointing down when I make my graph. Even negative, both arrows go down. Now this is interesting. I kind of have been avoiding negative leading coefficients because they're more difficult to factor. So when I factor x squared out as a GCF, I'm actually going to factor negative x squared out because everything will be easier. So take a negative out. And that's going to leave x squared minus 5x plus 6. So then factor that. Yes, but since A is 1, you don't have to rewrite the middle. You can just put it in parentheses. Some people, I mean, the good question students would always rewrite the middle, and that's okay.